All right, section 4.8, the sample size determination for different allocation methods. So far we have decided determine the sample size formula under stratified random sampling, and also we learn how to allocate the sample size into N1, N2 for each of the stratum. Now we want to put everything together with the given bound of error B and the cost. Then we want to we define the sample size formula under each of the allocation methods. So first of all, the optimal allocations. We have optimal allocations that we consider our samples allocations NL with respect to the total would be considering the population size, variability, and the cost with respect to the total of the populations. Okay, so if this is the case, we can substitute WL into equation 4.9 that we define the sample size equations. Okay, so I just copy that into my written notes. Under stratified random sampling, we show it how to find the sample size formula. Okay, so this is the sample size formula 4.9. It is defined, the sample size is bounded by the summation of NL squared SL squared out of WL divided by the denominator, which is a big thing. Okay, now we want to replace that WL under optimal allocations with this. Okay, so substitute this bit into WL. Let's try to assume the SL is not found yet because we haven't done the optimal, we haven't conducted the survey. So let's sigma L equal to SL in this case, replacing that. Okay, so copy equation 4.9 down here. N greater equals to summation NL square sigma L square divided by little WL, so which is to multiply the inverse of this. Okay, so summation goes on top and then this thing goes in bottom. Copy the same denominator, nothing changed. So what we have is NL sigma L could be cancelled out here by 1. And we have 1 over square root of CL. So in this case, this is in the denominator. So that, in other words, that could go up into the denominator. So what we have is summation of NL sigma L multiplied to square root of CL for the first bracket. Then for the second bracket, we have summation of NL sigma L divided by square root of CL. Okay, so two are different. Denominator are the same. So that's why we have these equations defined. So given the bound of error or the cost, then we can have a generalized equations for the sample size determination. Okay, for proportion, we simply replace sigma L by square root of P times 1 minus P. Under Lehman allocations, we only consider the population size and the variability of each stratum. So under the Lehman allocation, the WL is equals to NL sigma L divided by summation of NL sigma L. So substitute this at WL into equation 4.9. What we have is N is bounded by summation of NL square sigma L square multiplied to the inverse of this fraction. So we have summation on top. Again, we can cancel out one of the NL sigma L. So what we have is summation of NL sigma L multiplied to summation of NL sigma L. So that's why in the lecture notes, so we have same thing, they're the same, right? So take a square out of it, divided by n squared d squared plus the summation. Proportion replace sigma L by proportion. Okay, under proportional allocation, then the WL is NL out of N. So substitute WL into the equations of sample size, summation of NL square, sigma L square multiplied to inverse of these. So N divided by NL. Again, we can cancel one NL. So we have summation of NL multiplied to sigma L square. So we have capital N square. So cancel the capital N and cancel the N square. Then we have 1 over N. For the proportion allocations, the sample size formula would be this. Okay, similar for the proportion formula. Let's look at example 4.11. Find the overall sample size N and the allocations under the following situation. We are given the bound of error of estimation equals to 2 hours for my Y bar, the average hours of watching TV at the 95% confidence. Okay. Part 1, advertising firm use personal interviews, and then they found that the costs for town A and town B are equal, $9, but the rural area is $16. They have difference variance. So we need to determine the sample size under the optimal allocations. Okay. With the bound of error equals to 2, so D is around 2 out of 1.96, so this is around 1. Under the optimal allocations, this is the equation. Okay, so first of all, calculate the summation of Ni, sigma I divided by square root of Ci. So the summation of the 3 stratum. Also calculate this bracket, summation of Ni, sigma I, multiplied to square root of Ci. Okay, so these two multiply together, substitute into this equation, and divided by N square, D square, plus the summation of NL, sigma L square, that we obtained from example 4.7. So this is around 57.42. So we need to round up this to 58 to so the equation should be greater equals, right? So we need to round it up to 58 so as to satisfy the bound of error, the B requirement. Then we can perform the allocations. Out of the 58 sample size, how do we allocate into each of the town? So we follow the optimal allocations. For the first town A, the size N1 is equals to the total sample size multiplied to W1. W1 is defined as, in town A, what is the factor with respect to the entire population. Okay, so in other words, we are looking at population size multiplied to the variability divided by the square root of the cost out of the total. So in other words, if we do the calculation, we are actually looking at this bit divided by 800.83. So this is around 32% of the total sample size allocation. So it's about 18.5 or 18. N2, so about 39% of the sample size of the sample should go to N2, 29% should go to N3. Okay, so you notice that for the sample size overall, we need to round it up because we need to satisfy the requirement for the bound of error. But for the allocations, it is okay, it is fine to round it down to the nearest digit or even round it up, as long as the 3 add up must be greater equals to 58. Okay, so there's no strict rule on that to run it up or run it down for the allocations N1, N2, and N3. Okay, so part 2, the advertising firm use telephone interview. So now all of the costs are reduced and equal, and the variance equals to 10, they're all equals. So if this is the case, part 2, if we don't consider the cost and the variance, then we use proportional allocations. Under proportional allocations, the formula is given like this. So the total sample size is around 76. Then we do the allocation proportional to the population size in each of the stratum. Okay, so in this case, town A has the highest population, so about 50% of the samples should be allocated to town A. 3, the condition in part 1 follow, and the advertising firm has only $500 to spend on the sampling. Okay, so if this is the case, we only have $500 for the interview, but we would do our optimal allocations. Okay, under optimal allocations, we know that about 32% of the sample should be allocated to town A, 39% goes to town B, and 29% goes to town C, or the rural area. Okay, so how can we incorporate the costs into the consideration? We know that conducting the survey would be the cost per head multiplied to the number of sample. So we know that C1N1 plus C2N2 plus C3N3 would be the total cost. That should be bounded by $500. Okay, and we also can replace N1 by the proportion of the allocations. So substitute everything into this equation, we find that N could be equals to 500 out of 11.03. So we can do 45. So N 11.03 N must be less than equals to 500. So if that's the case, we need to round it down to 45. Okay, so out of the 45 sample, we do the allocations subject to the optimal allocations. Okay, so now we have the allocation 14, 18, 13. They add up, cannot be greater than 45 because we need to keep the cost below 500. So N, in this case, should be rounded down. Example 4.12. So now we are looking at the proportion of the 3 towns, and we have the error of estimates, the bound of estimations is limited by 0.1. The advertising firm used personal interview, the cost following part 1 of the previous example. So again, that would be optimal allocations. But now we are changing for the point of estimates is the proportion rather than Y bar, the average viewing times, right? So first of all, we calculate D. D is the bound of error out of the critical value. Let's say we use 4. So D squared is around 0.0025 for this problem. Use the optimal allocations formula for N. And again, should be greater or equals to this. Okay, so calculate each of the brackets in here. Substitute into the formula. We find that sample size is around 63. Do the allocations according to optimal allocations, and all the answers are found. Okay, so part 2, advertising firm use the telephone interview. So part 2, we would assume costs are the same, so we use limit allocations. So substitute into the formula, and then we can find the allocations accordingly. That's it.